Hi guys, in this video we will be dealing with Ostwlds dilution law. Alright, now Ostwlds dilution law speaks about weak acid. Alright, now acetic acid we know is a weak acid. Alright, so it dissociates this way. Now say in time t is equal to 0, that is in the starting time, we have taken 1 mole of acetic acid. Alright, and obviously it has not dissociated. So after time t, say it dissociates, its degree of dissociation is alpha. I've already talked about alpha, degree of dissociation. So alpha moles dissociates. So it is reduced by alpha moles. Alright, and here we obtain alpha moles. Alright, now we deal with concentration. So we know moles per liter is concentration. So in order to speak in terms of concentration, we have got to divide it by V. So now we are talking in terms of concentration, and we know equilibrium constant. Now this is an acid, so I would write it as Ka is product of concentration of products. Alright, so here the concentration for acetate ion is alpha over V moles, and same is also the concentration for H plus ion, alright, divided by concentration of starting material, that is reactant, that is 1 minus alpha over V. Alright, on calculation what we find is this becomes alpha square over V square over 1 minus alpha over V. Alright, this one V cancels, so what we end up with is alpha square over 1 minus alpha. Alpha square over 1 minus alpha. Alright, now we know that the dissociation is pretty low. Since it's a weak acid, so degree of dissociation is pretty low. So we neglect this alpha, and we forgot to mention that there's 1V coming down here. Alright, so there's 1V coming down here. So this is what, so the formula gets, our Ka gets to equilibrium constant for acid gets to alpha square over V. Alright, now we have taken 1 mole. For our purpose, we have assumed it to be 1 mole. Now suppose if we assume n moles, then obviously we would be multiplying n here also, here also. So as a result of that, here also we would be having n, here, and 1 n would be here. So this would be n square over n. So this one n also would go. So 1 n would remain here. So this would be n alpha square, and here also it will be n alpha square over V. Alright, n alpha square over V. Now we know that n over V, we know that n over V is concentration, moles per liter, moles n per liter V, so it's concentration. So we can also write it as Ka is equal to alpha square, n over V is what? Alpha square C, n over V is C. So this is yet another formula. So this was one formula which we got, this is yet another formula that we got. Alright, so if it is 1 mole, n disappears, and if it is n moles, then C comes into picture. Alright, so if it is so if it is 1 mole, then what? The equation for Ka would be, it would be alpha square over V. So this is the third equation. So here, in case number of moles is given and volume is also given, then you can use this formula for finding Ka. Obviously alpha, assuming that alpha is given, whereas in case concentration is given, n over V is given, then we can also get it converted to concentration and multiply it with alpha square, dissociation constant square. And if number of moles is just 1, then in that case this is the formula that we have got to use. Mind you, this is for 1 mole. Alright, And guys, in case you intend to find alpha, then what do? You take, now suppose this is the equation given, then you want to find alpha, this is the equation given, then you want to find alpha. So in this case, what happens? You just take, this becomes alpha square is equal to Ka over C. This goes down there, and then root both the sides, so it becomes the root of Ka over C. But in this case, what happens? It just goes there. So alpha is equal to, in case of 1 molar situation, V goes there. So this becomes Ka into V, alright, and a root. Alright, so this becomes for alpha in case of n moles, in case of 1 mole. Alright, okay then.